Part B asks, find the x-coordinate of each point of inflection of the graph of y equals g of x. So the original function, where does it have points of inflection on the interval from -7 to 5? And then we need to explain our reasoning. So let's not look at the graph and get freaked out like I've never done one like this before. Let's think about what we do know. Point of inflection. How do we know when there's a point of inflection? All right. Need to be careful. Don't use the word it. You've got to be specific, especially in your explanation. Lots of things can change from positive to negative, like your grades. What?
When the derivative of the graph changes from positive to negative.
Derivative of this graph, so the second derivative changes from positive to negative or negative to positive, right? That's basically going to be our explanation, right? The thought process helps us figure out that explanation before we even figure out the answer. Point of inflection is where the second derivative changes signs. Changes from positive to negative or negative to positive. Right? That's when we have an inflection point. So we need to look at this graph and figure out when does the second derivative change signs. Well, second derivative would be the derivative of the first derivative. That's what we have here in the graph. We have the first derivative. So our second derivative is the derivative of this, which means it's the slope of this graph. So let's look at this. For this first part, this whole line right here, what is our slope? Positive slope. That means we have a positive second derivative. How about this part of the semicircle? Slope is positive here still, right? How about from 0 to 2? Slope is negative. Negative slope means a negative second derivative. And then how about from 2 to 3? Positive. And then it's negative again. So where is it changing? Where's the second derivative changing? 0, 2, and 3, right? It's changing from positive to negative, negative to positive, positive to negative. So we have an inflection point. We have inflection points at x equals 0, x equals 2, and x equals 3. And explain our reasoning, because what we figured out to determine this, because the second derivative changes from positive to negative or negative to positive.